Okay, 5.5, Proving Congruence by SSS. Okay, so side, side, side. We talked about side angles, side before, so all of these are going to start following. You're going to understand them better and better, but specifically today we're just going to talk about side, side, side. So if three sides of a triangle are congruent to three sides of another triangle, then the two triangles are congruent. Okay, lots of abbreviations there to make my writing a lot faster. Okay, so just a good note-taking tool. Okay, so again, you can see three sides here that correspond to the three other sides are all congruent, so no need to write anything out there. All right, example 1, using the side, side, side congruence theorem, write a proof. So the first one, statements, reasons. Okay, again, segment KL is congruent to segment NL, and segment KM is congruent to segment NM. Okay, what does that tell me? Well, that gives me two sides, SS. So then I know that I'm only missing one side. Okay, obviously that was given. And the last thing that I need is LM. I know is congruent to itself, and it does not need to be flipped. I can tell from my proof that they're in the same location, so I can keep that as LM. What's it called when you're congruent to yourself? That is called reflexive. And that is a third side. So I have everything that I need. So you have triangle, write exactly what they write, KLM, it just makes your life easier, is congruent to triangle NLM by side, side, side. Okay. In example 2, explain why the bench with the diagonal support is stable while one without the support can collapse. Okay, so we have here that the bench with diagonal support forms triangles with fixed side lengths. By side, 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 they can't change shape, so the bench is stable. The bench without support can change shape since it's not stable. Okay, some of you maybe sat on a bench and it's kind of, you could like scoot it or wiggle it from side to side, like sway on it. Okay, and that's because there's nothing here like locking that into place. Okay, whereas this one, I know it's hard to see on my page, but this one does have one, so it's kind of stuck right where it's at. Okay, so moving forward here, let's talk about a hypotenuse. It is the side opposite the right angle. Okay, which you can see in the picture. And then the leg are the sides adjacent or next to the right angle. Okay, all right, so down here it says, you know that side angle side and side 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 are valid methods for proving that triangles are congruent. What about side side angle? In general, side side angle is not a valid method for proving that the triangles are congruent. In the triangles below, two pairs of sides and a pair of angles not included between them are congruent, but the triangles, sorry, hold on. I think I confused that. In the triangles below, two pairs of sides and a pair of angles not included between them are congruent, but the triangles are not congruent themselves, okay? So you can see that this angle is the same here, okay, and this side is the same here, and this side is the same, but whenever you change these angle measures here, okay, that changes the shape of the figure. Okay, so those triangles are not congruent. So while side-side angle is not valid in general, there is a special case for right triangles. Okay, so you will never use side-side angle or angle side-side. Okay, same thing. I should never see this forwards or backwards written on your paper, ever. Okay, all right, so let's turn the page and let's talk about this special case that only works for right triangles. Okay, and we have a special name for it as well. So theorem 5.9, hypotenuse leg congruence theorem, says that if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the two triangles are congruent. Okay, so only when it's a right triangle can you technically use side-side angle or angle side-side. Okay, and that angle has to be 90 degrees. Okay, it has to be a box there. It's the only way that works. And what we call it is HL, or hypotenuse leg. Okay, so in example 3, using the hypotenuse leg congruence theorem, write a proof. So statement, reasons. The first thing that they give you is WY is congruent to XZ. You know that WZ is perpendicular to ZY, and XY is perpendicular to ZY. Reason given. Okay, so first I see WY, I'm gonna kind of outline it here to kind of help you see, is congruent to XZ. Okay, and if you need to draw these out separately, do so. Okay, so that you can mark them a little bit clearer. So that whole thing is congruent to that whole thing. So this gives me a hypotenuse. Okay, I know that it's telling me a hypotenuse leg. If you did put side, okay, that's fine, but you're gonna realize soon that you're gonna have side-side angle, which only leaves you then with hypotenuse leg as a choice. Okay. All right, so to use hypotenuse leg, we have to show that we have right angles. Like I said, that's a necessity to have. So I know that angle WZY and angle XYZ are right angles. Okay, because these two things right here in the given told me that. And that is the definition of perpendicular lines. Okay, so then that means that triangle WZY and triangle XYZ are right triangles. Definition of right triangle. Okay, so now I have a right triangle. Okay, these two things are necessities. You have to tell me that you have a right angle, and you have to tell me that you have a right triangle. Okay, you cannot skip these. You will get points taken off. Okay, so then the last thing I'm missing, I know now that I have a hypotenuse, I'm missing a leg. So in step 4, I know that ZY is congruent to, well, ZY, it switches places to YZ, and that is called reflexive. So then in step 5, I'm just gonna write it really small right here so I don't have to make a new side. That triangle, use what they put, WYZ, is congruent to triangle XZY, and your reason over here is HL, okay? Because this was my leg. Okay, so I knew this was congruent to itself, and this made a right angle here and a right angle here. So whenever I look at this triangle right here, it looks like I have side-side angle or angle side-side, okay? But I know that I can't use that in a regular scenario. The only time I can use that is if it's a right angle right here, and because it's a right angle, it's called HL. Okay, so you do not write angle side side or side side angle here, you write HL. Okay, so then the last example, I believe, yep, is example 4. Okay, it says the television antenna is perpendicular to the plane containing points B, C, D, and E. Each of the cables running from the top of the antenna to B, C, and D have the same length. Prove that triangle EAB, triangle AEC, and triangle AED are congruent. Okay, so we are given that segment AE is perpendicular to segment EB. Segment AE is perpendicular to segment EC, and AE is also perpendicular to ED. Then we have that AB is congruent to AC, is congruent to AD. All of that is given. Okay, so I can see it here, but if you need to fill it in again, I can tell that this is a hypotenuse. Okay, and I can tell here that I'm going to have right angles. So in step 2 then, I have angle AEB, angle AEC, and angle AED are all right angles. Definition of perpendicular lines. So then I know that triangle AEB, triangle AEC, and triangle AED are all right triangles. Definition of right triangle. Okay, so then lastly, I'm missing my leg. So then I know that, step 4, I know that in my 3 triangles that AE is congruent to AE, which is congruent to AE. All reflexive. And that was your leg. So then in step 5, I have that triangle AEB is congruent to triangle AEC, which is congruent to triangle AED by HL. Okay, and you can see that there. We can go ahead and fill in. I have all of these right angles. Okay, and I know that AE is congruent to itself. Okay. All right, let me know if you have any questions. But again, the big takeaway today is that you may not ever, 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 ever write down angle side side or side side angle. Okay, don't write it down. It's wrong. It'll get you in trouble.